Let's graph a quadratic in vertex form. We have f of x equals a times x minus h squared plus k. Remember that the h tells you to go left or right, and the k tells you to go up or down, okay? And we're going to compare it to the parent graph. We have g of x equals negative 2, that's the a, x plus 2, that's the h, squared plus 3, which is the k. All right, and then we have the parent graph. Now, we've done the parent graph many, many times. We know by using a t-chart that the vertex is at 0, 0. We go right 1 and up 1, and left 1 and up 1. Then right 1 up 3, and left 1 up 3. And you graph your parent function quickly from memory to save you just a whole lot of time. So that's your f of x. Now, we're going to talk about the axis of symmetry first, and the axis of symmetry is always just whatever h is. And h, the problem originally was a minus h, and the only way I'm going to get a plus here is if it started out minus a negative 2. So my h is negative 2. That means my axis of symmetry would be h, so x is negative 2. I'm going to go over to negative 2 and put a dashed line where all the x's are negative 2. Okay, now the vertex is going to be hk, which is negative 2, 3. So I can go left 2 and up 1, 2, 3, and there's the vertex. Because a is negative, this thing should be going up, downward instead of upward, so it's a reflection. All right, and now I want to show you why the vertex worked real quickly. If you plug the negative 2 in right here, where the x's are, we would get, I'm just showing you why it is what it is, we would get negative 2 times 0 squared plus 3. And 0 squared is 0, and 0 times negative 2 would be 0 plus 3. So that's the reason it works. Negative 2, 3. We just have to remember that it is the hk, so you can do it quickly. All right, now I need to test some other points. I know it's going down this way, and one of the points that's really easy to test is when x equals 0. So let's let x equal 0 to get a point and the symmetric one. So if x equals 0, I've got g of 0 equals negative 2 times 0 plus 2 squared plus 3. All right, so that's negative 2 times 2 squared plus 3. That's negative 2 times 4 plus 3. That's negative 8 plus 3, which is negative 5. So I want to plot the point 0, negative 5. So 0, 1, 2, 3, 4, 5 would be here. And since it's symmetric and it's 2 away from the axis of symmetry, it would be another point right here. Okay, I really have a long enough parabola, but I need one of these points in between here and here. So that's like negative 1. So let's let x equal negative 1. And plug it in and see where that would end. Okay, so I have negative 2 times negative 1 plus 2 squared plus 3. So negative 2, negative 1 plus 2 is 1 squared plus 3. So 1 squared is 1, so I have negative 2 plus 3. Negative 2 plus 3 is 1, so I have the ordered pair negative 1, 1 to graph. So left 1 and up 1 would be here. And then there's a point here. So let's trace. Kind of missed that one. And graph that one. Now let's talk about and compare those. All right, so what we see is G opens downward and it's narrower than F. The vertex of G is on negative 2, 3, where the other one is at 0, 0. It's 2 left and 3 units up. It will be a vertical stretch by a factor of 2. It's a reflection in the x-axis. I believe that's all I can say about it.